Hello buckaroos and buckarettes. I posted a video yesterday called Adding Vectors To, and I showed two different ways to add vectors. I went completely through the solution one way, and the other way, which required the law of cosines, I just sort of said, here, use the law of cosines, called it good and pretty well signed off. Well, I got a request to complete that solution. Go through the solution using the law of cosines, because that's something people are familiar with. Well, that seems like a really fair thing to ask. So let me just go through that same problem using the geometric method and the law of cosines. So what I want to do here is I've got two vectors. I'm going to call them A and B because I don't really apparently have any sense of creativity. And A goes 1 in the x direction, 1 in the y direction. B goes 2 in the x direction and minus 1 in the y direction. Well, how do you write that mathematically? Because I don't know how to write 1 in the x direction, 2, that doesn't work too well. So we have these things called unit vectors, and a unit vector is either in the x or y direction. There's actually one in the z direction as well, and at least in principle you could have as many of them as you wanted for every direction you're using. Okay, so the unit vector I, which has this little caret at the top of it, is a length of 1, the unit vector, and it's in the x direction. Okay, so it's a little boilerplate piece of vector that goes in that direction only. Y, J goes only in the y direction and also has a magnitude of 1. So if you want to make a vector, these are kind of like vector Legos, if you want to think about them that way. You can make any vector you want by adding however much of that plus however much of that. You can get a vector of any magnitude in any direction. So if I take 2 of those and minus 1 of those, I can make that vector. All right, that works pretty well. So I want to add these up. Well, I could do it algebraically and add those up. I did that in the other video and it worked out. You can see that the j's are going to cancel out and you're going to wind up with 3i. So the right answer is along the x-axis and goes out to 3, right about there. The other way to do it is to go geometrically. And it doesn't matter which order you do this in, but let's say I want to add A first and then B. So I'm going to make a vector C here. And I'm going to say it's the sum of A and B. Okay, and again, it doesn't matter whether you do it in that order or that order, you're going to get the same answer. So I go up to A, and then I follow the instructions for B. I go over 2 and down 1, and I'll get to right there. All right, and we already know that's 3i. Okay. Again, because the j's cancel out here and you're left with the i's. Well, that's the this is the algebraic way. This is a geometric way, sort of. Here's how you do it using the law of cosines. All right, I need a magnitude here. Well, that's magnitude there is square root of 2. And the magnitude here is going to be 4 squared plus 1 squared, so that's the square root of 5. Okay, A, I already know 1, I know that's 45 degrees. Okay, now, or alpha I should say, delta, okay, now it depends on how you look at this. That's delta, but so is that, because here's the angle going down from there, here's the angle going down from here. They're on, these two parallel lines are on opposite sides of a horizontal axis, so this angle must be this angle. Is that angle positive or negative? Well, it depends on how you look at it. If I look at it from here, delta is going to be the inverse tangent, of minus 1/2, and you get 565? Yeah. 565 degrees. Now over here, you look at it this way, that's 1 and that's 2. This one's going to be positive, that's going to be negative. That's going to be positive 26.565 degrees. So watch your minus signs there, friends. So I'm going to call this 26.565 degrees. I hope that's big enough y'all can see it. Well, the only thing I need now is I need to know what B is. If I'm going to use the law of cosines, I'm going to be beta. I have to know what beta is. Well, beta, remember the internal angles of a triangle add up to 180 degrees, right? Okay, we learned that in, I don't know, trig, I suppose, in high school. And so if I add those 3 up, it has to be 180. Well, if I know what 2 of them are, I know that beta has to be let's see, 180 degrees minus 45 degrees minus 26.565 degrees. And if you work all that out, we're not going to try to do it in my head here, 108.435 degrees. 108.435 degrees. So that's beta up there. So we got it. Now, we got everything we need. I have magnitudes of both of those, and I have that middle angle. Now I'm ready to do the law of cosines. Let's see, how about if I do this over here? I'm going to call that distance there C. Now, it's not C hat, or that doesn't have that little caret over it now, because this isn't really a vector anymore. It's just the side of a triangle. Okay, now that's a very subtle distinction to make, but it is an important one. Okay, so what I'm going to do here, say C squared equals A squared plus B squared. Like you, I had to look it up. AB cosine beta. All right. So that's straight off of, I got it off of Wikipedia, but I went to the Googles and it told me how to do this. Back in the old days before the internet, you had to memorize all this stuff. Let's see, 2 plus 5, because that's square root of 2 squared, square root of 5 squared, minus 2 times, that's going to be cosine 108.435 degrees. And you work all that out, you're going to find out C equals 3, just like it did there. Okay, so I hope that helps. The thing to remember, hopefully, is that this method right here and this method are mathematically identical. You can tell I got the sun out right here. Mathematically the same thing. It doesn't matter which one you're doing, you're solving the same problem, and if you use the methods correctly, you'll get the same answer both ways. All right? So there you go. There's the law of cosine solving that same problem. Hope this helps, and I'll talk to you next time.